We need to talk real quick, make sure we understand how to put meters into a circuit. We spent a lot of time with this in lab. I'm going to remind you here that we've got, as well as the symbols that we've discussed for circuit elements, we've got the symbols for a voltmeter and ammeter. And a voltmeter measures the potential difference between 2 points. So it's measuring the potential at one point. Let's say we wanted to measure the potential difference across a resistor. We measure the potential at one point. We can call that V2, and we measure potential at another point. We can call that V1, and it wants and what the voltmeter does is it just measures the difference, V2 minus V1. So a voltmeter must go into a circuit so that it is measuring at the voltage or the potential difference on either side of a device. So we need to wire it to a circuit so that the voltmeter is wired so that each wire is attached on either side of a device. So if I want to measure the voltage or the potential difference of the power supply, I can hook up a voltmeter there, etc. Right? So if I have a series circuit and I want to measure the potential difference, IR, across a single resistor, I'm going to put a voltmeter across that resistor so I can measure the voltage on one side and the voltage on the other side, and I can find out the difference between the two voltages across that resistor. So in this case, V is going to be, if this is R1, I1, R1. It'll measure that. In this case, if I put a voltmeter here, V is going to measure delta V of the power supply, etc. Okay, so voltmeters go into circuits like that. Ammeters measure the current through something. So if I've got a circuit and I want to know the current going through something, let's just draw a bunch of circuits. Let's say I want to measure the current. Let's go into the top circuit and I want to measure the current that comes out of the battery, goes through R1 and comes back to the battery. If I want to measure the current through it, then if I took an ammeter and I attached the ammeter like this, notice what happens is that the ammeter shorts R1. Now, let me actually explain a little more about the voltmeter. The voltmeter, let me go back and explain about the voltmeter. The voltmeter here is shorting the resistor, right? But it's not actually shorting the resistor because a voltmeter, because we hook it up across something, if it had no resistance, it would short it and it wouldn't allow the current to travel through the device, right? So the current, if the voltmeter had no resistance, then the current would come and go that way and no current would go that way. So a voltmeter must have an infinite resistance, right? The resistance of a voltmeter must be infinite so that it doesn't take any current away from the device. A voltmeter must have an infinite resistance so that it doesn't take any current away from the device. If it has an infinite resistance, then no current is going to go through the voltmeter. Now, in reality, what's the resistance of a voltmeter? The reality is that there's no such thing as a real infinity. Infinity is large. That just means large, right? Large resistance. And what does large mean? Large means that a voltmeter that you use better have a resistance that is much larger than the resistance of the device that you're measuring the voltage of. In other words, let's just take this situation, the bottom circuit. The resistance of the voltmeter here better be, voltmeter, better be much, much larger than the resistance of R1. That's why a voltmeter has a switch where you can change scales. What that scale does is it allows you to change the resistance of the voltmeter that's appropriate for the thing that you're measuring the voltage across. Now let's contrast that to the ammeter. The ammeter wants to measure the current through something. Well, if the ammeter is measuring the current through something and I hook it up like I show here, then what it's doing is, how is it going to measure the current through it? Because what it's going to do is the current is going to go that way, and that current is going to be dependent on the resistance of the ammeter, not the resistance of the device. So that's not a useful way to hook up an ammeter, and you do not want to hook up an ammeter that way. So let's go ahead and erase that. you can redraw it in your notes and say ammeters do not want to be hooked up that way. They don't work, because then you're not measuring the current through the device, you're measuring the current through the ammeter, which has to do with the internal resistance of the ammeter, not the resistance of the device. So an ammeter measures the current through something. So an ammeter better be, if we want to measure the current through R1, then that same current can go through the ammeter. So an ammeter is going to go right into the circuit, right? And that's why, right? So the ammeter goes into the circuit. And that's why I always say you break the circuit and put the ammeter in. So what we do in practice is we're going to break the circuit where we want to put the ammeter and take it and go through the ammeter and then connect the circuit back up. So now whatever current goes through R1 must also go through the ammeter. But you say, but the ammeter's still going to impact the current through R1. Well, it's not if what? What is the resistance of the ammeter? The resistance of the ammeter must be 0. If the resistance of the ammeter is 0, then it won't impact the circuit. Now, is it really 0? No, but an ammeter is made to have a small resistance so that you don't impact the current in the circuit. So that's only approximate, right? It's small. The ammeter must have a small resistance, at least small compared to the resistance that you're measuring the current through, so that it doesn't have as much of an impact on the circuit as the resistor that you're trying to measure. Okay, so if I want to measure the current through R1, where do I put the ammeter? Now let's look at this circuit. If I want to measure the current through R1, where do I put the ammeter? Well, what if I put the ammeter here? There, if I put the ammeter there, isn't it measuring the current through the battery? Yes, but the current is the same everywhere. So therefore, it doesn't matter where I put the ammeter. But if we wanted to, if we want to get close, it really doesn't matter. In lab, we just pretended, right? We put the ammeter there, we put the ammeter there, and we put the ammeter next to the power supply and showed that they're all the same, so it doesn't matter where you put it when you're in series. In parallel, right, if I want to measure so now let's look at this circuit over here. If I want to measure the current through R1, I had better put the ammeter, in this branch of the circuit. Don't put it here, don't put it there, because what that's doing is measuring the current through the battery. It's not measuring the current through R1. And if I want to measure it through R2 and R3, I can put it here, or here, or here, right? So those three are all the same current, right? That's the current through 2 and 3. Okay, that's meters. Have a great day.
Why does a moon rock taste better than an Earth rock? It's just a little meteor.
Ha ha, serious, funnier than me.